You've probably been there, right? Sitting in that super quiet room, headphones on, just waiting for that tiny little beep. But a hearing test is so much more than a simple checkup. It's a full-on scientific investigation, a mission designed to find the absolute limits of your perception. So what are they really looking for with all those beeps? Well, that's exactly what we're going to decode today. And believe it or not, it all starts by creating the perfect, almost eerily silent conditions for discovery. Think about it like a detective story. Before you can find any clues, you've got to secure the crime scene, right? Well, in this case, that means creating a super controlled environment to isolate the one and only thing that matters, your sense of hearing. You see, to get a truly reliable result, they have to eliminate any possible, contamination of the soundscape. That's why you're in a soundproof booth. It's why they make sure those headphones fit just right. It's all about making absolutely sure that the only thing you're reacting to is the test itself, nothing else. And the instructions they give you, that's actually the biggest clue of all. They always say something like, raise your hand as soon as you hear the beep, even if it's very soft. And that right there, that tells you everything. This isn't a test to see if you can hear a loud, obvious noise. Oh no. This is a search for the quietest, faintest sound you can possibly detect, the absolute edge of your perception. Okay, so how exactly do they find that super quiet sound? It's not just random beeping, I promise you. There's a very specific, highly structured method they use. It's kind of like a game of hot and cold, all designed to zero in on a very precise target. Let's call it the down 10, up 5 game. Now, the official term for this target is your hearing threshold, and this is where it gets really precise. Notice that definition, reliably hear 50% of the time? It's not about hearing a sound once by some fluke. Nope. They need to find the level you can catch at least half the time. That's what makes the result truly scientific and trustworthy. And this is how they do it. It's basically a search algorithm for your ears. They'll start with a tone you can definitely hear. You raise your hand. Okay, they drop the volume by 10 decibels. You hear that one too? Great. Down another 10. Whoops, you missed that one? No problem. They bring it back up by 5. See the pattern? This down 10, up 5 dance is the fastest, most efficient way to zero in on your exact hearing threshold. So here's a key takeaway. Everything we've just described, the soundproof booth, the headphones, the beeps, that's all part of what's called air conduction testing. It's named that because the sound travels through the air in your ear canal. It's testing the whole system, the entire pathway. Your outer ear, your middle ear, and your inner ear, all working together. But, and this is the interesting part, that's only half the story. So that first test was just step 1. Now the investigation is about to get a little weird, because the next test doesn't even involve your ear canal. It's all about hearing through your bones. For this part, they use a little device called a bone oscillator, and they place it on the mastoid bone, that hard bump right behind your ear. Instead of sending sound waves through the air, it sends tiny vibrations through your skull that go directly to your inner ear, completely bypassing the eardrum and the middle ear. So why on earth do both? Well, because comparing the two results is the key piece of detective work. If you can hear perfectly through the bone, but you struggle to hear through the air, what does that tell you? The problem isn't your inner ear. It has to be some kind of blockage or issue in the outer or middle ear. And just like that, the audiologist has pinpointed the location of the problem. Pretty clever, right? Okay, so far, the investigation has been pretty straightforward. But what happens when the audiologist suspects the person they're testing isn't being, entirely truthful? Turns out, there's an incredibly clever test for that too. Now, this can sometimes happen, maybe for legal reasons or for compensation claims. But how do you test the hearing in an ear that someone claims is completely deaf? Well, you use a fascinating little trick of the human brain. It's called the Stinger principle, and it's based on a simple, weird quirk of how our brains work. If you present the same sound to both ears at the same time, you will only perceive the one that's louder. Your brain literally doesn't even register the softer one, and this little quirk is what makes the whole test possible. So here's the setup. They play a soft tone in the good ear, one they know the person can hear. At the exact same time, they play a much louder tone in the poor ear, the one they claim is deaf. The trap is now set. And here is the brilliant reveal. If the hearing loss is real, what happens? They'll hear the soft tone in their good ear and raise their hand. Simple.
But what if they're faking it? Their brain, thanks to that stinger principle, will automatically lock onto the louder sound in their so-called poor ear. And to keep up the act, they can't admit they heard it, so they stay silent. No response means a positive stinger, and it's basically proof that they heard the sound loud and clear.
So, after all of this detective work, the air conduction, the bone conduction, maybe even that sneaky Stanger test, the audiologist is left with a whole bunch of data points. Now it's time to put all the clues together to get one single meaningful number.
The analysis really hones in on the three frequencies that are most critical for understanding human speech. That's 500, 1000, and 2000 hertz. So here you can see the example thresholds they found for each one using that down 10, up 5 search we talked about.
The final step is actually pretty straightforward. You just combine these key data points. By taking the average of the thresholds from those three critical frequencies, you get a single, powerful number that summarizes a person's overall hearing ability for speech. And there it is, the pure tone average, or PTA. In this example, it's 42 decibels. This one number gives a quick, reliable snapshot of someone's hearing in the range that matters most for communication. It's the final answer to the entire investigation. So, as you can see, a simple hearing test is way more than just beeps and buttons. From creating perfect silence to using the brain's own quirks to find the truth, it's an amazing scientific process. It's a great reminder that just beneath the surface of our everyday senses, there's this incredible world of complexity, just waiting for us to decode it.